Hello and welcome to another video for Advanced Topics in Algebra with Financial Applications. This one is about graphing systems of linear inequalities, and how this has a financial application might not be obvious at first, but this leads us into a topic called linear programming that has direct application to finance and business. Here's a system of equations, and you can tell that it's a system because of this big curly bracket right here. That big curly bracket means it's a system of equations, which means that we're looking for solutions to both the top equation, or in this case, inequality. See the less than symbol? That makes it inequality. And the bottom inequality. Notice that both of these are in standard form. So the best way to graph these is to use the intercept method. I guess that technically you could put them into y equals mx plus b, or slope-intercept form, but I think that that would be extra steps, and since the equations are inequalities, are given to us in the form of standard form, using the intercepts method is the way to go. So here's an example. Looking at this example that's right here, we've got 3x plus 4y is less than 12. I'm going to graph the inequality on the top first, of course, and in this case I'm going to use red. So looking at this, if I cover up 3x because x equals 0, then I've got 4y equals 12. Divide both sides by 4, and we get y equals 3. That means that the point 0, 3 is here on our graph. By the same logic, if I cover up 4y because y equals 0, then I'm left with 3x equals 12. Divide both sides by 3, and I have x equals 4. So the point where x equals 4 and y equals 0 is on our graph. Now, please notice that in this top inequality we've got less than. When it's less than, that means that values that are equal to 12 don't work. That means simply that we have to connect these dots with a dashed or dotted line, and it's going to continue on off in the same direction till infinity. Pretend that red line is straight. Same thing for the second inequality, 5x plus 2y is less than 10. That means that when x equals 0, we have 2y and we have 10, meaning that when x equals 0, y equals 5. There's that point on the blue line. Similarly, if y equals 0, then x equals 2, which is going to be right about there. And since this is 5x plus 2y is less than 10, rather than is less than or equal to 10, again, this is going to be a dashed line, and it's going to continue on forever. Now, it's the shading that we have to look at. Looking at the top inequality, the one that we did in red that has 3x plus 4y, that means that I'm going to shade where this is less than. So this whole side of the inequality gets shaded. Notice I'm doing it in red, and I'm doing it from top left to bottom right. I'm going to do a similar thing for the blue line, but I'm going to shade in blue everywhere that the blue line holds true. Now, if you can see, that means that there's a zone that goes like this, and I'm using dashed lines down to where the blue and the red line intercept, and then I'm going to switch from tracing the red line, which is lower, to the black line, which is lower. So here, in this area where both red and blue are shaded, this is what we call the zone of feasibility. Our answers to our question. The question is this system of equations. where on the plane could we find answers to this that would make both inequalities true? Well, it's here in this zone of feasibility that I'm now shading black. Overshading, I got a little excited. But notice that the part over here that is just blue is not part of the zone of feasibility. And this down here where it's just red, not part of the zone of feasibility. And of course, everywhere out here where it's left blank, not part of the zone of feasibility. Only in here where I overshaded it in black, where the red and the blue overlap, that's the zone of feasibility. Now you try it. Here's another one. This is on your worksheet. This is letter B on your worksheet that was handed out. I want you to notice that this inequality sign is a less than or equal to, as is this one. And this is a system of linear inequalities. So what does this sign mean that's different from just less than? It means you're going to use a solid line. That means that any values that make 6x plus 7y equal to 42 are valid, as well as any values that make 6x plus 7y less than 42. That's what it means when we represent that on the graph with a solid line rather than a dotted or dashed line. So pause the video, go do that problem on your worksheet, then come back to see the explanation of letter C, which will be briefer. So you're back. I assume you've done letter B now. This is letter C. Please notice that y is less than 200. Where's the x in that inequality? In fact, there isn't one. There's a special way to graph that, and I wanted to point it out in this problem. Also, please notice that we've got much bigger numbers. We've got numbers in the hundreds and hundreds of thousands over here, rather than just up into numbers that are around 10. Looking at a graph, that would mean that my numbers here on the x-axis I'll want in hundreds. Rather than just 1, 2, 3, 4, 5. We'll see how this plays out. We might need some adjustment. Again, I'm just going to mark this one 100. That should tell us, by looking at this graph, that the rest of the spaces are the same as this space. So from 0 to 100, 100 to 200, etc. Helps me find them without having to write all those pesky numbers. Looking at this first part, y is less than 200. The fact that it's a less than means that it's going to be a dashed line. And we are just looking for a dashed line at y equals 200. Now you may not know it, but if it's just y is less than 200 or y is equal to 200, that just means I'm going to have a horizontal line. Please notice that no matter what the x value is along this line, the y value is 200. And in terms of shading, we're going to shade this area down here. The area that is less than 200. Switching to my other color, I'm going to look at the next inequality. Looks like one of my zeros was cut off. In my next inequality, we've got 500x plus 300y is less than or equal to 150,000. Taking that, if we assume that x equals 0, we're here somewhere on the y-axis, aren't we? Anywhere here that x equals 0. So plugging x equals 0 into that, we've got 300y. Divide that by 300 and divide 150,000 by 300, and we're left with the point 0, 500, which is right here. And notice I'm combining symbols here. This one is less than or equals to. That means we're going to use a solid line. Additionally, if y equals 0, we're here along the x-axis somewhere. And when y equals 0, 500x is less than or equal to 1500, divide both sides by 500, we've got the point 300, comma 0. So I'm going to make a solid line going between those points, and I'm going to continue it on, and continue it on in this direction. And then for shading this, we're looking for the overlapping region. I'm going to shade the blue everything that is less than or equal to So here's where we're shading. Please notice, there's a zone out here where neither of the inequalities are true. It's all left blank. Over here, it's just blue. Over here, it's just red. What we are looking for is the area here inside this zone of feasibility where the red and the blue overlap. Any of the points in this zone here make both of these inequalities true at the same time. Any point that's in here, for example, the point 0, 0, will make both of these true at the same time. More on that at another time. But right now we're just looking for this zone of feasibility. Now for letter D on your worksheet, here's a similar problem. You go ahead and try that one. You don't have to pause the video because I will explain the answer in class if you'd like. And we've reached the end. For now anyway, thank you very much.